Assalamualaikum. We are from Group 3. We'll present about the hydrology project. This subject is BFC32002 hydrology. We are from section 2 and the lecturer's name is Dr. Hartini Binti Kasim. Okay, next. This is our team member. First one is Muhammad RaFiq ROZI, matrix number CF220160. Lutfi Hazim bin Selamat SAINUDIN, DF 230119. Ahmad ADLI AIMAN bin Abdul Rahman, DF 230126. ZAKI IRFAN bin KHAIRUN NIDZAM, DF 230090. And the last one is AINUL MARDHIAH binti SHAIFUL NIZAM, DF 230081. For the introduction, the climate Malaysia is equatorial with hot, humid and rainy weather through the year. Rainfall is obtained with minimum amounts rarely dropping below 100 mm in any given month. When the rainfall exceeds the soil capacity to absorb water, it leads runoff, which is the most significant component in the hydrographic map during a storm. Rainfall includes surface runoff and contributes to the flow of the river. The component and impact of rainfall on water level and river flow are influenced by factors such as topography and land use. Water level data is gathered at varying frequency depending on the purpose, with quick observation take over days, weeks or months for groundwater study. The data for this study was collected over a month in February from station Sungai Pahang Lubuk at station Sungai Pahang at Lubuk Paku.
Okay, next for methodology. To conduct this hydrological project, we were choosing a series systematic approach for methodology in the location Pahang, Malaysia. This location was chosen based on the availability of water and hydrological area. After locating the rainfall station and the water level station, the setting of the procedure and application was conducted based on objectives including the data collection and data interpretation with the help of some application. The application was the official hydrological website and Google Earth Pro in order for the objective was successfully achieved. Okay, next, Department of Irrigation and Drainage. The Department of Irrigation and Drainage is a government agency that works to effectively manage water resource, encourage the best use of land, and maintain environmental sustainability for the country of Malaysia. In addition, the ID is in charge of basin management, hydrology and water resource management, flood control, and environmentally friendly drainage. The ID's original primary goals include design projects pertaining to water utilization, including maintenance and upkeep of this project, as well as development initiatives in the field of irrigation, drainage, river engineering, and resource assessment. In this project, the water level and rainfall are presented and located by using the Department of Irrigation and Drainage website. The various rainfall and water level stations were located at Public Info Banjir, which is using the same website before. Okay, next hydrograph. The data collection for the rainfall and water level station on the proposed area in Pahang is recorded by using hydrograph. The hydrograph was illustrating the activity of water in a specific time. For the hydrograph in figure 2.3 show the data of water level at the station that have been chosen, which is Lubuk Paku Maran. It was collected for 1 month, which is from 1st February 2023 to 28 February 2023. Other than that, the hydrograph of water level in station Sungai Pahang at Lubuk Paku is shown in figure 2.4. And then Google Earth Pro. Google Earth Pro is an extremely high resolution satellite that can be leveraged to view the location. It is a free software that allows visualization, overlay, and creation of geospatial data. Other than that, this application also can help to explore 3D terrain, dive in 360 perspective of Earth, and zoom in the specific location that we want. This app also allow you to explore any place in the world and is useful for learners who have a passion in learning about GIS and start with basic process and tools. Thus, As shown in Figure 2.5, is an application that was used in this project to identify and analyze the geographical of hydrological stations such as terrain profile, gradient slope, and cross-section of river. And then I will present about case study location. For this project, the case study that has been chosen was located at Pahang, Malaysia. This is one of the places that has experienced heavy rain or light rain almost every day for this 1 year. During the wet season, they will always prepare to face that monsoon that coming from northeast that bring heavy rain. By seeing how close the area in Pahang it is to the river, there are high risk of flooding. The biggest river there is Sungai Pahang, but it didn't stop for another river to overflowing to land. For example, Sungai Tembeling and Sungai Rompen that were overflowing and made netizens worried. Therefore, the Department of Irrigation and Drainage helped to analyze the rainfall and water level station in the area around Pahang, so it will assist in creating an effective strategy on managing the flood. During the research, the rainfall station that was found is located at Lubuk Paku Maran, while the water level was located at the same location as shown in figure. Next in figure was shown Lubuk Paku that was located at Maran and it was located near river.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is LUTFIL HAZIM Selamat SAINUDIN. My number meter is DF2030119. Okay, I will present to you about method of rainfall analysis. Rainfall data collection involve real-time monitoring of water level for station. Observation include daily rainfall and total precipitation over the preceding 24 hours. Mean the rainfall estimates the average depth of precipitation over a region for a given period. Peak flow denotes the maximum discharge rate during runoff caused by storms or floods. Okay, this method have three methods we can use to find the mean rainfall. First, associated method. Associated method is connect lines joining points of equal rainfall and plot station location. Okay, in the upstairs, D is the formula of the associated method, and secondly, arithmetic mean method. Arithmetic mean method is calculates the average precipitation depth. Then simplest method using arithmetic average. We usually saw the say arithmetic method in the every question. And thirdly, Tyson polygon method. Tyson polygon method is determine area close to sample points. Construct polygons between station. Okay, this is the equation for Tyson polygon method. Okay, for the peak flow, we have two methods. First, rational method. Rational method is predicts peak runoff on small areas, determine discharge from drainage area. Okay, you can see the equation for the method and the rational method. And secondly, Manning method. Manning method is calculate flow rates in open channels. Employs Manning equation. Okay, for the next part is geographical characteristic. Okay, there is include weather, climate, landforms, and soil. Project location feature hills, riverbanks, and area prone to flooding. Catchment area collect water rainfall directing it into rivers and streams. You can see in the map of Google Earth Pro, you can see the catchment area, our station. Okay, for the terrain profile and gradient slope, we, terrain profiles analyze elevation change. Gradient slopes are calculated for PET segment. PET 1 has a gradient slope of 0.177%. You can find the gradient slope in the equation of the perfect slope. Rise per run multiply by 100. Okay, these are the map of the data of terrain profile and gradient slope. Okay, the lastly for my part is terrain profile and gradient slope. We have three cross section depicted terrain picture. You can see the all three map for our cross section for this project.
Assalamualaikum warahmatullahi wabarakatuh. My name is ZAKI IRFAN bin NIZAM, and now I will present about the data analysis and result. And based on the data that we obtain, we will find the peak flow by using rational method. So peak flow is described as the maximum flow of a stream during a rainstorm event, and it is important to analyze the peak flow for drainage facilities. And we can see in the hydrograph, the highest peak is called as peak flow. For this calculation, we will be using a lot of Google Earth Pro to get the data of area, the data of slope. We can estimate the data very accurately, and we will also find other values such as runoff coefficient by using the MSMA second edition. We just put into the formula given. We will also find the slope of the overland surface and the time of concentration, and also the IDF empirical equation for Pahang. This data is obtained by using the MSA second edition website. So we just put inside the formula, and the chosen station is Pintu Kau Pulau Kertam because that is the closest station towards our catchment boundary area. And based on our calculation, we managed to obtain that our peak runoff, which is our peak flow, is 1086 191.15 meter cube per second. Alright, now I will be presenting the data analysis and result for Manning method. So Manning method is described as one of the methods for indirectly estimating stream flow based on slope and cross-section area. It is used to calculate the amount of water that flows through a specific place in a river. The Manning method formula is Q equals to 1 per N AR to the power of 2 divided by 3 and S divided 1 to the power of 1 divided by 2, which is the formula in the slide that you can see. And we actually will be using this formula to calculate three different types of cross-section, which is the upstream, the middle stream, and also the downstream. So we will do calculation about 3 times for each different cross-section. And for the cross-section, we use the Google Earth Pro to estimate the length and the height of the trapezoidal shape of the cross-section. And at the end of our calculation, we managed to get the data of discharge for our upstream, midstream, and downstream. And we were also able to calculate the average peak flow just by dividing by adding them up and dividing them by 3. And the data like Manning roughness, weighted parameter, cross-sectional area, hydraulic mean radius can be gained just by using the formulas. So at the end, we will get the discharge for each cross-section. Alright, so now I will explain about hydrograph, which is the last thing for our group project. And hydrograph is a rainfall. Hydrograph is a graphical representation that shows how rainfall can impact the flow of water in a river or station over a period amount of time. By multiplying the area of the river's cross-section by its velocity, we can calculate the discharge, which refers to the amount of water that passes through a specific point in the river per second. So basically, hydrograph is the graph that we can make, and it is the y-axis is discharge, meanwhile the x-axis is time, and our time is date. And based on our hydrograph, we choose February month. So there are about 28 days that we have to plot in the graph. And before we have to plot the graph, we have to find the discharge value. So this is done by using Microsoft Excel, because we can use the calculator, but it would take a lot of time. And by using the Microsoft Excel, inserting the values and formula, it really saves us a lot of time. Then we can find the discharge value. And then after that, we will also use a straight line method in order to find the UH ordinate. Depending on what cross section, like the example that I give right now is upstream. So we will find also for midstream and also for downstream. So this procedure is repeated 3 times for it's repeated once for every cross section. And for the straight line method, we just assume one point to another point, and most of the time it's like around 7 days. And based on the data right here, it's 6 February until 13th February, and we managed to get the UH ordinate, which is based on the calculation, based on the formula. And we will be able to plot another UH, which is unit hydrograph of the cross section, which is the upstream, that is here, that is in the slide. And at the end of our calculation, we will also manage to find the value of equivalent runoff depth. And that is just it for the calculation. There is also midstream and downstream calculation, but I didn't show in this slide because there is too many. But in our report, it is presented and the calculation is shown there. So that is just for me. Thank you.
Conclusion. The study looks at floods in Malaysia, focusing on Station Sungai Pahang at Lubuk Paku to find out which areas are at risk and how to prevent flood damage. In February 2023, data was collected for 28 days. Using tools like Google Earth Pro and data from the Department of Irrigation and Drainage, the team calculated average rainfall and river discharge. They recommend taking steps to prevent flooding, educating the public about flood risk, and preserving natural water retention areas like meadows and forests. Good urban planning in flood-prone areas is also essential to reduce flood impact. Thank you.